Hello viewers, welcome to Diffusion TV. Now let us take a look at this question, and of course this question is going to be based on Graham's law of diffusion. In some of our lessons previously, we have stated we have given the statement of Graham's law, and of course we say that Graham's law states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Or we can say that Graham's law states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass. Alright, so the question reads here that 100 cm cube of oxygen gas diffuses through a porous partition in 10 seconds. How long will it take 60 cm cube of chlorine to diffuse through the same partition under the same condition? And of course, we're given atomic mass of oxygen to be equal to 16. That of chlorine is equal to 35.5. If you see this kind of question, please don't panic. If you have seen this kind of question before, or anytime you come across this kind of question, don't panic. It's very, very simple. Just come close as we solve this. Okay, so let us solve this problem. Let us solve this problem. It's very, very simple. We say solution. From our statement of Graham's law, we say Graham's law tells us that the rate of diffusion of a gas is inversely proportional to the square root of its molar mass or its density. So in this case, we are going to use this expression that says that rate of diffusion of oxygen gas, RO2 means rate of diffusion of oxygen gas, all over rate of diffusion of chlorine gas, okay, chlorine is Cl2, is equal to all square roots. Since we say that the rate of diffusion of the gas is inversely proportional to the square root of its molar mass, so we are going to have molar mass of chlorine on top here. Molar mass of chlorine. MmCl2 simply means molar mass of chlorine. Whereas we are going to have molar mass of O2 here. Of course, MmO2 simply means molar mass of oxygen gas. Alright. So the first thing we need to do here is we should find our rate of diffusion of oxygen, rate of diffusion of chlorine gas, our molar mass of chlorine gas, and also molar mass of oxygen gas then. Okay, now look at, since we are given volume and time, how do we find our rate of diffusion? Anytime, be guided or be reminded that anytime you are given volume and time, how do you find your rate of diffusion? You just simply say that rate is equal to volume diffused all over time taken. That is the volume of the gas that diffused all over the time it takes for the diffusion to take place. So whenever we are giving volume, like in the case of this question here, volume 100 here, and of course time in 10 seconds, how do you determine your rate? You just simply take the volume of the gas that diffused divided by the time it takes for diffusion to occur. Alright, so we go this way. Let us look at the rate of diffusion of oxygen gas. So rate of diffusion of oxygen gas is going to be, volume of oxygen gas given was 100 cm cube. And of course, the time it takes for oxygen gas to diffuse, according to the equation, is 10 seconds. 10 seconds. So when we divide 100 cm cube by 10 seconds, we are going to obtain 10 cm cube per second. This simply means that in every 1 second, in every second, 10 cm cube of the gas will diffuse. So this is the rate of diffusion of oxygen gas from the equation there. Okay, let us go down. The next one is rate of diffusion of chlorine gas. RCl2 simply means rate of diffusion of chlorine gas. Now, for chlorine gas, we are giving volume of 60 cm cube. And of course, we know that for us to determine our rate, we take the volume and divide it by the time taken for the diffusion to occur. Now, we are not giving time for diffusion of chlorine gas, and it is even the time that we are required to calculate. So we still put there that volume diffused all over time. So this is going to give us time of diffusion of chlorine gas TCl2. Okay. Yes, this is the time of diffusion of chlorine gas. So it will not change. This is just the time of diffusion of chlorine gas, or this is the rate of diffusion of chlorine. Volume diffused all over time it takes. Okay. Since there is no number here, we can't divide 60 by an unknown here. So it will remain like that. So that simply means that the rate of diffusion of chlorine gas is just 60 it is 60 divided by TCl2. TCl2 simply means time of diffusion of chlorine gas. Okay, let us go over to this side. I think we are now going to use this expression. Okay, yes, let us go. Now, the next thing we are supposed to look at is the molar mass of chlorine gas. MnCl2 simply means molar mass of chlorine gas. Remember, we are given atomic mass of chlorine gas to be 35.5. So for us to find the molar mass of chlorine gas, we are going to say 35.5 times 2. And of course, this should give us 71 gram per mole. Okay, how about the molar mass of oxygen gas? MnO2. Molar mass of oxygen gas, since each of the atom of oxygen is 16, so we say 16 times 2. Because in oxygen gas, there are 2 oxygen atoms that combine to form oxygen molecule, which is a gas. So we are going to have 32 gram per mole. This is the molar mass. So we have been able to find our rate of diffusion of oxygen, molar mass of chlorine, molar mass of oxygen, but we don't know our rate of, the time for diffusion of chlorine gas. Alright, so we now put this into our expression. Rate of diffusion of oxygen, we want to substitute everything into our expression. Rate of diffusion of oxygen was calculated to be 10 cm per second. That of chlorine is 60 cm³ divided by TCl2. That is still going to be 60 divided by time of diffusion of chlorine, since there is no number here. Okay, let me put everything here like this. It's equal to, it's going to be equal to all square root. All square root. Remember, the molar mass of chlorine is going to be on top that we have calculated, 71 all over molar mass of oxygen, which is 32. Alright? Now, if we take the square root of 71 and then divided by square root of 32, we are going to obtain approximately 1.5. We are going to have something like 1.489, but approximately it should be 1.5. So whatever we have inside this square root here is going to be 1.5. So permit me, let me repeat everything here. So we are going to have 10 all over 60 divided by time of diffusion of chlorine is equal to 1.5. We know in mathematics, anytime we have a fraction like this, 10 divided by 60 divided by TCl2, what we are going to do in a very simple way, just multiply what is down here by the number on top and then divide by what is here. Multiply what is down here by the number on top and then divide by the number down here. So in that case, we are going to have 10 times TCl2, we are going to have 10 TCl2. Okay, and then I divide by this number here, which is 60. All is equal to 1.5. Alright? So we can even make this one a fraction and then we cross multiply. We can make this a fraction and then we cross multiply. If that happens, we are going to say 10 TCl2 times 1 is the same thing as 10 TCl2. Okay, it's equal to 60 times 1.5 is going to give us 90. It's going to give us 90. So at this point, we can divide both sides of the equation by the coefficient of the known. And of course, the coefficient of the unknown here is 10. Everything divided by 10. So that this 10 will divide this 10. So what we are going to have the TCl2 simply means time of diffusion of chlorine is going to be 90 divided by 10. And of course, 90 divided by 10 is going to give us 9 seconds. It's going to give us 9 seconds. This, if you have any problem on how to perform calculation on Grant's law, follow my videos on YouTube at Eugene TV. Follow me, subscribe to Eugene TV on YouTube. You can also go to TikTok, Eugene TV 101. Just type there, Eugene TV 101. You'll see a whole lot of videos that will guide you on how to perform calculation on Grant's law. Thank you and bye for now.